If you keep an aquarium in Southern California, as I do, or anywhere with hard tap water, you already know this. It's the white crust that appears on equipment and hardscape. The TDS reading that climbs week after week between water changes. The glass that needs vinegar rather than a sponge. This is the mineral concentration problem. Water evaporates, but the dissolved minerals it contains do not. They stay behind, and they accumulate. The internet will tell you several things about this. It will tell you to top off with distilled water instead of tap. It will tell you that plants will help. It will occasionally tell you both at the same time without specifying which matters more. I am a biology teacher. I do not find the internet says satisfying, so I designed an experiment. We start with 3 identical 2-liter containers. Same tap water as the starting point. The only differences are going to be our deliberate, controlled, and documented changes. The first one is our control. It's going to have nothing in it. The second one is going to be our tap water one, where we're going to fill up with tap water when we're done. And finally, the third one is going to get filled up with distilled water at the end. Everything else, the light, the temperature, the starting volume, the plant species, the mass of such, are all going to be as identical as possible. Here is what each comparison is going to tell us. How much does plant growth actually reduce dissolved solids relative to top-offs alone? Are we going to have some sort of switching from tap to distilled? Will that actually help? Is there a baseline that we can compare to? What happens to the TDS when you do absolutely nothing except for replacing the evaporated water with the same water that it came from? We're going to measure our parameters at the start, and then we will end up measuring them again after a week, and then after 2 weeks. We're going to be using a TDS probe, and we're going to measure pH, GH, and KH via these test strips that are easily obtainable. They're not the best, but we should be able to see slight changes as we go. And who knows? It could be that the TDS could be going up because of minerals. It could be nitrates. It could be both. The GH and the KH will let us separate the mineral hardness fraction from everything else. This distinction is the entire point. If one tank's plants grow significantly faster than the other, that's a variable that we will need to account for. More growth means more nutrient uptake, which would confound the comparison, and we are certainly watching for that. Because if there's one thing in all of biology, it's that things will happen differently. You will never get a straight line. Water evaporates as pure H2O. The mineral ions that are dissolved in it, calcium, magnesium, bicarbonates, sodium, chloride, these will not evaporate. They will stay behind. Every time water leaves the tank and you replace it with tap water, you are adding a fresh dose of minerals to the remaining concentrated minerals. The tank is not exchanging minerals for fresh water. It is accumulating minerals, topped off with more minerals, indefinitely. This is why correct top-off liquid is not tap water, but usually distilled or reverse osmosis water. Water with no dissolved solids. When you replace evaporated water with pure water, the mineral concentration stays constant rather than climbing. You are replacing like with like at the correct chemical level of abstraction. The GH and the KH, general hardness and carbonate hardness, are the specific fractions of TDS we most care about in hard water. GH measures the calcium and magnesium ion concentration. The KH measures carbonate and bicarbonate alkalinity. Together, they account for the dominant mineral hardness in most tap water. My tap water is extremely hard. Our baseline GH is seen by our test strips and will be on screen. And by the end of this experiment, our control's GH will be considerably higher than that. The question is, how much? One more thing to watch for: calcium carbonate precipitation. When the pH rises above approximately 8, and calcium and carbonate concentrations are high enough, the two ions can combine and precipitate as a solid calcium carbonate, the white crust that you see on your aquarium equipment and glass and everything else. In planted tanks with active photosynthesis, the pH rises as CO2 is consumed, which can trigger precipitation. If this happens in our planted ones but not our control, it is itself a TDS reducing mechanism, but an abiotic one, not a plant one. We are watching the tank walls. Day 14. The data is complete. The graph waiting to be drawn. Here is what we found. The TDS graph. 3 lines, 14 days. Look at what's happened. The control. It had a tap water top off. No plants and no intervention. The TDS started at 304 parts per million and climbed to 389 parts per million over 14 days. That is a 29% increase from evaporation-driven concentration alone. The ending top-off added more minerals. Nothing removed any. The line goes up, and it does not come down until we add more water. Our tap water top-off with plants. The TDS started the same at 304 parts per million and reached 371 parts per million, a 22% increase, lower than the control. The gap between the tap water top-off and control is 21 parts per million. That is the plant effect. The plants consume some of the nutrient fraction of the TDS, the nitrates, the phosphates, the potassium, from any organic input, but they did nothing to the mineral hardness fraction, because plants do not consume calcium carbonate. They consume nutrients. Those are not the same thing. Our distilled water top-offs with plants. The TDS started the same at 304 parts per million and reached 342 parts per million. The gap between the two tanks is 29 parts per million. There is a confounding variable between the two planted tanks that will be seen to some effect in the GH of the test strips. Baby snails. The plants helped a little. Note that the top-off at the end has significantly helped the overall TDS. The GH data makes the argument more precisely, although much more hard to read via test strips. The GH measures calcium and magnesium ions, the actual hard water minerals. The plants in the tap water top-off tank did not reduce the GH. Plants do not extract calcium and magnesium in quantities that compete with evaporation-driven accumulation. The GH in our distilled top-off did decrease, however. Remember those snails? Guess what they build their shells out of? Calcium and magnesium. And the component breakdown. The GH is approximately 150 parts per million of calcium and magnesium. The KH, approximately 50 parts per million of carbonate hardness. Add them together and you have 200 parts per million, and that is the mineral fraction of your TDS reading. Subtract that from the total TDS and you get the nutrient and organic fraction. The tap top-off's nutrient fraction is 171 parts per million. The control's parts per million is 192. The difference is 21 parts per million. That's what the plants did. Everything else was minerals. So, can plants lower your TDS? Yes, modestly. By consuming the nutrient fraction, the nitrates, the phosphates, potassium. They reduce the portion of TDS that comes from the biological activity and fertilization. They cannot touch the mineral hardness fraction. The GH and KH are not plant food. Calcium and magnesium accumulate regardless of how many floating plants you have, because the mechanism driving the accumulation is evaporation, not biology. The solution to hard water concentration in a closed system is not more plants. It is correct top-off practice, replacing evaporated pure water with pure water, distilled water, reverse osmosis water, zero TDS water. If your tap water is hard, topping off with tap water is the problem presenting itself as the solution. The distilled top-off proved it. Same plants, same light, same starting water, same duration. The only difference was distilled top-offs. And a little bit of snails. TDS, GH, and KH all stayed significantly lower. Not because of chemistry beyond evaporation, because of exactly the chemistry of evaporation, correctly understood and correctly addressed. This experiment started with a question the aquarium hobby answers imprecisely. Does topping off with distilled water help, and do plants help? The answer from the data: yes to the first, considerably and measurably. Yes to the second, but modestly and in a limited way. If your water is hard, plants are not the solution to mineral accumulation. They are a solution to nutrient accumulation. Those are different problems, and they require different answers. We will run different iterations of this in the future. I, for one, am now curious as to the power of snails to lower the GH. If you want to run your own version of this experiment, the full protocol is pinned in the comment below. Your aquarium is a mostly closed system. What goes in stays in until you take it out. The data confirms it. Now, you know what to take out and how.